Hello everyone, so we are continuing our work with polynomials and we're moving on to trinomials, a very special kind of trinomial. In particular, we're going to be looking at something called quadratics. A quadratic is just a trinomial that takes the form of something like this, x squared plus maybe 2x plus 6 or something like that. It has usually an x squared or y squared and a squared, some kind of squared variable in the front, and then you've got your x variable. It can have a coefficient. There can be a coefficient here as well. Technically there is. There's our nice little visible one there, and then it finishes off with a constant. So this is typically what a quadratic looks like, and quadratics or trinomials can be expressed as a product of two binomials. So let me clear the board and we're going to do an example and I'm going to show you what that looks like. So I'm going to clear the board and we're going to start off with a nice little example here. We're going to look at a couple of strategies of how we can multiply two binomials together. So let's say we have x minus 4 times x plus 2. So we've got a binomial times a binomial. And remember, binomial is just a polynomial with two terms. That's it. There's one term there. There's x minus 4 is your second one, or x and plus 2. So it's just a binomial, and we're going to multiply these together. Now, the first strategy I'm going to show you is kind of nice. It's a nice little visual way to do it. And we're going to start off by drawing ourselves a little rectangle. In fact, this is called the rectangle diagram. And we've seen a method kind of like this, or you may have seen it, I should say, back when you were learning how to multiply 2-digit or 3-digit numbers together, because you can use this diagram for that kind of stuff as well. So what we're going to do is I just divided this up into 4 squares, or rather 2 columns and 2 rows. And the reason why I divided it into 2 and 2 is because we have 2 terms in each of our in each half of this product. So what I'm going to do is, let me color code some stuff here. I'm going to call this our orange side, and I'll put this guy down here. So that's x. I'm going to line that first term up with this first row, and then the second term I'm going to line up with the second row. So we've got x and our minus 4 down there. The next thing that I'm going to do, we'll do a yellow side, is we're going to do something similar, but we're going to line up each term with the 2 different columns. So we've got x there, and then our plus 2 there. You could just call that 2. You don't really need the plus sign, but I like to include it to be consistent. Now, what we're going to do is we're just going to look at the squares, and we're going to, inside here, we're going to put the product of the corresponding outside terms. So in this first square here, we're going to go x times x, which is x squared. That's all we're going to do. And we're going to do that for all 4 sections of this rectangle. So the next one, if we go just to the next one in that row, we have x, and that lines up with the orange x and the yellow plus 2. So we're going to go x times 2, or 2 times x, it doesn't matter. And that's going to get us a product of 2x. If we drop down to the first column in the second row, we've got something similar, x times minus 4 and minus 4 times x, to get us minus 4x. And then last but not least, we have our minus 4 times our plus 2, which gets us minus 8. Now, this is kind of nice. It sets up all of the terms that we're going to have to add together. So if I go back up here, what this tells us is that x minus 4 times x plus 2 equals x squared plus 2x, take away 4x, take away 8. It's that easy. Now, we're not completely done here because, and you might have recognized something, is that we have like terms right there. So we can actually simplify this a little bit, clean it up, and that's exactly what we're going to do. So we're just going to, our x squared doesn't change, nothing changes there. The only thing that changes is our x term. So we've got a positive 2x and a minus 4x. You can treat this with the same strategies you would just by going plus 2 take away 4, right? That x still follows the rules of mathematics, as I always say. The rules don't change. So we're just going to go plus 2x, take away 4x, and that's going to get us our minus 2x. And then, again, our minus 8 doesn't change. Now we're done. That's a finished answer right there. Now, we could do a different method. So we'll call this method 1. Actually, I'll put that up here. method 1, and this is called the rectangle diagram. Now the second method, I'll say method 2, uses something called the distributive property. Distributive property right there. So that's kind of a big word. Let's describe what that actually means. So if we have our example again, we have our x minus 2, or sorry, x minus 4 times our x plus 2. That tells us that the distributive property states that x minus 4, in this particular example, x minus 4 times x plus 2 can be rewritten as x times this whole term, x plus 2, and we're going to add that to minus 4. Now since we're adding a negative, I'm just going to go ahead and put that minus sign there instead. Minus 4 times x plus 2. So that's the distributive property in a nutshell, is that we can rearrange this, that the product of these two sums is the same as the sums of every product that you could possibly get out of this. So let's break that down a little bit further. Well, for this section here, again, we just multiply that outside term by all of the inside terms and then add them up. So x times x is x squared, x times 2 is 2x. Now we're going to do something similar over here. Minus 4 times x is minus 4x. Minus 4 times 2 is minus 8. Now this should look familiar, right? Because it's the same thing that we did up top, right? Just different strategy. And again, we can combine our like terms. We've got our like terms there, and we end up with our x squared minus 2x minus 8. So that's how you use the distributive property. Now for binomials, or sorry, when you're multiplying two binomials, you might have heard of FOIL, right? Which stands for first, I'm actually going to undo that and I'll color code this. So FOIL first, outside, inside, and last. So all that means is that multiply the first terms in each one, and we did that. That's how we got that. Then multiply the outside terms, which is, you know, the outside edges, and we did that, right? We did that right here. That's how we got that. Then multiply the inside terms, which is those two right there, and that's how we got this guy. And then multiply the last terms, right, which is how we got that minus 8. And then this last step was, oh, we didn't actually finish that. And then the last step is just simplifying it down and combining like terms. So that's the two different methods that you can use for multiplying two binomials. And actually you can use this strategy if this was a binomial times a trinomial. We'll talk about that later, but you can use the exact same method. Same thing with the distributive property. It's not only for two binomials. In fact, this is also, when we went from here to this step down here, technically that's also taking advantage of the distributive property, and that's only a monomial times a binomial, right? So different types of polynomials being used for multiplication, but the distributive property still applies. And we will do more examples later on, but for now that's all I have for you. So anyway, I hope that helps, and if you have any questions, of course, feel free to reach out, and we'll be chatting with you. Stay safe, everyone.